Hello everyone, welcome back to Genius Tutorial. So in this session we are going to take a wonderful problem based on relations topic, and in this question what we are going to deal with, it is given to you that if R1 and R2 are two equivalence relations on a particular set A, and we need to prove that R1 intersection R2 will also be an equivalence relation. So that means what is given to you, it is given that R1 and R2, these are two equivalence relations, and we need to prove that intersection of two equivalence relation will also be an equivalence relation. So let us first understand what is an equivalence relation. So to prove a particular relation to be an equivalence relation, we need to prove that the particular relation is reflexive, we need to prove that it is symmetric, and it is transitive. So if we can prove all these three conditions, we can say that the particular relation will be an equivalence relation. Now what is reflexive relation? A relation R is said to be reflexive if AA belongs to R for all values of A belong to that particular set. Symmetric means that if AB belongs to R, then BA should also belong to that relation. And transitive means that if AB and BC, these two ordered pairs belong to relation R, then AC should also belongs to R. And if I say that these three conditions hold, then we can say that relation is an equivalence relation. Okay. So now the definition of equivalence relation is, I hope this is clear to you. Now it is given that we have two relations R1 and R2. They are equivalence relations, that means they are satisfying these three conditions. We need to prove that their intersection R1 intersection R2, that will also be an equivalence relation. That means this R1 intersection R2, this will satisfy these three conditions. This relation, it will be reflexive, it will be symmetric, as well as it will be transitive. So let's try to verify each of the condition one by one. So now first of all, let's verify whether this relation is reflexive or not. We need to prove that R1 intersection R2 is reflexive. Now how to prove that? We know that R1 is reflexive and R2 is also reflexive. Reason being because it is given that R1 and R2 both are independently, both are equivalence relations. So that means they must be reflexive also. Now if R1 is reflexive, then we can say that AA should belong to R1 for all values of A. Okay. Same way we can say AA should belong to R2 for all values of A. Got it? Now AA belongs to R1 as well as to R2. We can say that this AA should belong to R1 intersection R2 because this lies in both the relation. So this will be a common part. Okay. So we can say that AA belongs to R1 intersection R2 for all values of A belongs to A. Now since AA belongs to R1 intersection R2, we can say that therefore R1 intersection R2, this will be reflexive in nature. So we have verified the very first part, that R1 intersection R2 is reflexive in nature. Let's move on to the second point. We need to verify whether R1 intersection R2 is symmetric in nature or not. So if I need to prove that R1 intersection R2 is symmetric in nature, we need to take that if AB belongs to R1 intersection R2, we are going to consider this, that AB belongs to this R1 intersection R2, and what is required to prove here? We need to prove that its inverse, that means BA, that should also belong to R1 intersection R2. So now let's verify this. Now since AB belongs to R1 intersection R2, this means AB belongs to R1 and AB belongs to R2. Because AB belongs to R1 intersection R2, that means AB is the common part. It will belong to relation R1 as well as to R2. So AB belongs to R1, and we know that R1 is symmetric in nature because R1 is an equivalence relation. So it must be symmetric. And same way we can say R2 is also symmetric. So if R1 is symmetric, we can say this implies that BA should belong to R1 and BA should belong to R2. That means BA should belong to R1 intersection R2. That's what we need to prove here. So that means we can say that therefore R1 intersection R2, this is symmetric in nature. So we have verified the first part, that R1 intersection R2 is reflexive in nature. Same way we have proved that R1 intersection R2 is symmetric in nature. Now let's move on to the third part. That means we need to verify the third property, that this R1 intersection R2 is also transitive in nature. So how to prove that? If I say that if AB and BC, this belongs to R1 intersection R2, we need to prove that. What is required to prove here? Required to prove is that AC should also belongs to R1 intersection R2. Now let's see whether it is true or not. Now since AB and BC belongs to R1 intersection R2, we can say that this AB and BC belongs to R1 and they belong to R2 also. And we know that R1 is transitive. Why R1 is transitive? Because it is given in the question that R1 is equivalence relation. And same way R2, this is R2. R2 is also transitive. So since R1 is transitive and ABBC belongs to R1, we can say that AC belongs to R1. And same way we can say AC belongs to R2. Now since AC belongs to R1 as well as to R2, we can say that AC should belong to R1 intersection R2. Okay, and that's what we need to prove here. So we can say that therefore R1 intersection R2 is transitive also. Now this relation is reflexive, symmetric and transitive. So we can say that R1 intersection R2 is equivalence in nature. That means this is reflexive, symmetric as well as transitive. So we have derived that intersection of two equivalence relation will also be an equivalence relation, and not only for two relations, it can be extended to three also, R1 intersection R2 intersection R3, or to 4 or to n number of relations. Okay, so we can say that intersection of two relations is an equivalence relation. Now my question to you is, you have to tell me whether union of two equivalence relations is an equivalence relation or not. Okay, as we have proved this for intersection, you have to tell me union of two equivalence relation is equivalence or not. Okay, you have to give your answer in the comment section below. I hope you enjoyed the session today, and if you have any doubt or any query related to that, you can give your feedbacks in the comment section. Okay, thank you so much.